Okay, welcome back. So, in an effort to shorten the time on this video, since it's similar to a couple of the other videos I made, but potentially a little more tedious, I have solved some of the quick steps, or not quick, but some of the tedious steps that by now probably you are okay with. So, this differential equation, non-homogeneous, we want to find the general solution, which is the complementary plus the particular. To get the complementary, we do need the homogeneous equation solved. We know the form of these solutions are going to be e to the rx. When we plug that in, we end up with the characteristic equation of r to the fourth minus 3r cubed plus 2r squared plus 2r minus 4 being equal to 0. Notice over here I wrote a couple of the synthetic division steps. This just tells us that we know r minus 2 is a factor, and we also know that r minus 1 is a factor, or sorry, r plus 1 is a factor. And that gives us the coefficients for the last factored term, which is going to be r squared minus 2r plus 2 being equal to 0. Now for this, r squared minus 2r plus 2, we do need to use the quadratic formula to figure it out really quick. That's going to give us negative b, so 2 plus or minus the square root of b squared, which will be 4, minus 4 times a, which is 1, times c, which is 2, over 2 times a. When you simplify that, you end up with 1 plus or minus I. And when we get a complex solution for r, we can write the solution in this form: e to the at times constant times cosine bt plus c2 times sine of bt, where a is the real part, b is the imaginary part, the coefficient of the imaginary part. So in our case, we now essentially have found what our complementary solution will be. We know r equals 2 is one of the forms, so we could write constant times e to the 2t. R equals negative 1, so it's constant times e to the negative 1t. And then we have our complex form, which is going to be e to the a, which is 1, so e to the t, times c3 times cosine of b, which is just 1, so it's cosine of t, and I keep putting t, but it really should be x, because that is the form we are using. So used to doing the t's. So c1 e to the 2x plus c2 e to the negative x plus e to the x times c3 cosine of x plus c2, sorry, not c2, c4 sine of x. So that is our complementary solution. And from there, we need to get our our particular solution. So our particular solution, because we have this e to the x times 2 cosine 2x minus sine 2x, we can say a particular solution will be of the form where we have some function of x times e to the x, and we can potentially make things a little nicer for us. To find the derivative, we got to find the derivative 4 times using the product rule. And when we do that, I am going to, again, for the sake of time, just write what you end up getting when you simplify after using the product rule. Although in this case, I'm just going to leave it. So u prime e to the x plus e to the x times u, which again ends up just being e to the x u prime plus u. Y double prime, again, when you have it in this form, you can just use the product rule, and it kind of becomes a little straightforward, a little more straightforward. So you end up with e to the x u double prime plus 2u prime plus u. And the triple prime, again, using the product rule, you end up with e to the x times u triple prime plus 3u double prime plus 3u prime plus u. And then the fourth derivative, once you take it and simplify the terms, you end up with e to the x times u, the fourth derivative of u, plus 4u triple prime plus 6u double prime plus 4u prime plus u. And if that wasn't enough, we now have to plug all this information into our differential equation and simplify some more. So, writing that out, we know we have the fourth derivative, so that's just going to be e to the x times u, the fourth derivative, plus 4u triple prime plus 6u double prime plus 4u prime plus u minus 3 times y triple prime, which is e to the x, u triple prime plus 3u double prime plus 3u prime plus u plus 2y double prime, so 2, and y double prime is e to the x, u double prime plus 2u prime plus u plus 2y prime, so y prime is e to the x, u prime plus u, and the last term minus 4 times y, and y is just e to the x times u. And that is equal to the right side, which is e to the x times 2 cosine of 2x minus sine of 2x. And here you could see there's a commonality of e to the x, so we could essentially divide that out, and that will simplify things relatively nicely to u, the fourth derivative of u, plus u triple prime minus u double prime plus u prime minus 2u, all being equal to 2 cosine of 2x minus sine of 2x. So that's nice. So dividing the e to the x out, and then of course simplifying all the primes and such, you get this fairly straightforward, maybe differential equation involving u of x, and we can now say u of x will look like the form of a constant times cosine 2x plus another constant times sine of 2x to kind of match this right side's form. And when we plug that stuff in, I'm not going to write that part, again, for the sake of saving some time. You do just plug these into the differential equation, and then you'll combine like terms, and what you end up with is 18a minus 6b cosine of 2x plus 6a plus 18b times sine of 2x. And that is all equal to 2 cosine of 2x minus sine of 2x. And this is nice because now we can match the coefficient in front of each term. So 18a minus 6b will equal 2, which is the number in front of cosine of 2x. And then similarly, 6a minus 18b is going to be equal to the coefficient in front of sine of 2x. So that's going to be 6a plus 18b being equal to -1. And again, I'm not going to just do the algebra here. I'll leave that to you. I will just give you the result that a equals 1/12 and b equals -1/12. And that gives us our nice u of x, which is, I'm just going to factor out the 1/12, and that will leave us with cosine of 2x minus sine of 2x. And then we recall that we were trying to find y of x, not u of x. We just did that to hopefully keep things in order easier. So our particular solution is going to be e to the x over 12 times cosine of 2x minus sine of 2x. And then, of course, because I wanted the general solution, the final step is to just combine the complementary with the particular. So that will be c1 e to the 2x plus c2 e to the negative x plus e to the x times c3 cosine of x plus c4 sine of x, and then plus our particular solution, e to the x over 12 times cosine 2 of x minus sine 2 of x. And that is our general solution to the differential equation.